index laws. So some of you might have learnt these index laws as just a bunch of rules. That's how I learnt them. And to be honest, I didn't realize until I was after university, I was doing my teacher training, that I never really actually understood how all of these worked. I just learnt them as rules. And I was like, yeah, that's just what it is. So that's why. And we really should be challenging like how they work. So I'm going to just explain the background of some of these, because for some people, if you know why they work, it makes them easier to remember. So these index law questions likely to come up on the non-calculator paper, your first exam, if you're doing a non-calculator paper, but it will be on any exam board are going to test this. Indices are a topic that always comes up, and the exams are much more uniform than before. So all this content, whether you're AQA, EdXL, IGCSE, whatever you're doing, indices is a big one. This is coming up, and it's probably coming up early on in the paper. And it's all or nothing questions. You either know how to do it or you don't. So there won't be like loads of method marks, but you know, it's kind of 0% or 100%. So I want to be able to do a question like this, because we might be like, yeah, I'm happy something to the power of 0 is 1. And then you get faced with a question like this for a couple of marks, 2 or 3 marks, and you perhaps don't know how to solve it. You haven't got your calculator. What do you do? So I want to break this up and show you how to approach this meticulously. And hopefully that question will be answered in a minute. But yeah, we're going to follow along. And I appreciate as well, you're looking at slides and you maybe just jotting notes, rough working for now, as we go. And then, you know, afterwards you'll be able to review everything we've done. But yeah, it's fantastic to have everyone engaged with each question as we go, because you can really challenge or you know, put things in the Q&A about steps I've done, and I can go back and stuff. Let's have a little look at this one. So we need to know how to work this out. There is no hiding with this. And what we need to do is look at the index laws first. So if you've actually started this or you know how to do it, feel free to work ahead of me and try to do it without a calculator, because I'm pushing that this will probably be a non-calculator skill. If it's typing it in, we can do that. So we need to look at what rules this uses. So 25 over 9 to the power of minus 3 over 2. It's kind of got everything in it. It's got a combination of rules. It's got a negative power, and it's also got a fractional power. And it's a fraction itself. So it's just like really got the worst case scenario here. And knowing hopefully that something to a minus power is 1 over, which I'll talk about in a minute why that is. You can combine these rules together and break this question up. So what I would advise with these harder ones, so it's all animated in a kind of quirky way, just to kind of take the serious edge off of this, separate it out, break the scenario up. This, to be honest, this content I've prepared is higher content, but a lot of this first bit would be in both. So up till lunchtime, this is content that can be in both. But I'm actually trying to pick out the worst case scenarios and really attacking that. Okay, so I hope that answers your question. Now, what I just want to show you is that this power can be split up into 3 ways. It's up to you how you do it. It's got a minus part of it. It's got a fractional part, something over 2, and it's got 3. And when you have a power to a power, you times it all together. So minus 1 times a half times 3 is minus 3 over 2. And you could actually break it up in any of these ways. The point is we're having an acknowledgement of this kind of 3 things going on with that power. So either separating this out could maybe be a mark or could be on your way to a mark. And then I would pick the way that I would find this easiest to do. So I would personally pick, if there's a fraction, deal with the fraction bit first. Deal with the denominator, the half. Something to the power of a half is the square root. Then it's being cubed, and then it's to the power of minus 1. And if you're looking at this and you think, I'm really struggling with this is quite tough, then, you know, don't panic, because I'm actually going to go how these rules work in a minute. But I do want to just walk us through this one. So what we'll do, we'll walk this through together, and feel free to make a note of this on paper or in your own time. But basically, I would deal with the half bit first because that's the worst bit of the power. And something to the power of a half means square root. So well done if you knew that. But we're going to square root that first. And I would leave it as a fraction for non-calculator papers because it's easier to square root a fraction than it is to square root a decimal. So 25 can actually be square rooted and 9 can be square rooted. And you can use the question to your advantage because you might have noticed they were both square numbers. And then you might think, oh, maybe it's to do with square roots. It might actually remind you. So if we square root that, we deal with that first power. It's almost like composite functions. You're doing the innermost thing first. You get 5/3. So I've dealt with the half problem. I've square rooted. The next step, hopefully we can see, is to take that thing and to do what? The next thing would be to cube it. We're going to cube whatever's come out of that. So if we 5/3, we cube it, we get 125/27. And then the final step is to do the reciprocal because the -1 power flips it. And we get 27/125. Cool. So that was a big, quite challenging question. But I want to now answer some of these rules and explain them if you are struggling with indices and these harder questions. One of the questions I got asked when I was doing my teacher training is, why is a number to the power of 0 1? And I really struggled to answer it. It was kind of like, because you just have to learn that. It kind of just is. But let's think about it really carefully, and this will explain some of the rules nicely. If we look at the powers of 2, as you work up the powers, effectively, what are we doing? How do I get from 2 to 4 to 8 to 16? We times by 2. So as we work down the powers, what are we doing? We're dividing by the base. We're dividing by 2. So if you carry that logic on, 2 to the 1, if we divide by 2, you get 1. And then what happens is the negative powers basically is a continuation of dividing by 2. So what we get is 1 and then 1/2, then 1/4, then 1/8. And so the negative powers actually mirror the positive powers, but in the denominator. And that's why the minus powers do the reciprocal. They sort of flip it, they turn it fractional. And I've never really thought of it as going up and down the power sort of route, but that is what we're doing. Think of a division, think of it as a division. If you go down the powers, you're dividing. And if we bring in some other numbers to look at this, so other powers we can do easily, powers of 10, they're kind of lovely. Powers of 10, 10, 100, 1,000, and so on. And as you go down the powers, you divide by 10. So that would mean that 10 to the 0 is 1. And 10 is pretty cool because you can kind of count the number of zeros. But this pattern will be true whatever the base is. You're just doing the number divided by itself. So the power of 0 is always 1. And as a result, if you keep going, the negative powers are like 1/10 or 1/5, and so on. So in every case, anything to the power of 0 is 1 because it's the base divided by itself. Now, if you've just committed that to memory, brilliant. When it comes up as a 1 marker, make sure you get the marks. It says 22 to the power of 0. The answer is 1. Okay, excellent. Now, the other question that I think addresses the hard bit about what we just did, why is something to the power of a half square root? This is something I've never really had to explain until I started teaching. I just accepted. But let's go through it. So something to the half times something to the half, x to the half times x to the half. Remember, when you times with the same base, you add the powers. So what is that? What is that equivalent to? X to the half times x to the half is x to the 1, which is just x. So something times itself gives me the number x. So how can that work? The only way that can happen is if that thing was the square root. If I have a number, something times itself gives the number, that number is the square root of it. So root x times root x is x. So basically anything to the half means the square root of the thing, because when you times it together, it makes one whole power of that thing, because you'd add the power. So hopefully that brings to life why the power of a half is square root. That's what it means. Now, oh, it's the same again. So with an example, root 5 times root 5 is 5. So effectively 5 to the half means root 5. Now, what we've got, this is a kind of quite a tricky question that a lot of people lose marks, they get a bit stumped with. This probably would be the end half of the paper actually, but we might as well do it now while we're looking at indices. And I want us to think about how we would approach this, because even if you did have a calculator, I don't think it overly helps you with this question if you don't know where to start. So work out the exact value of x. 16 to the power of a fifth times 2 to the x equals 8 to the 3/4. Now, the trick here is all about the base. Okay, there you go. You can channel Megan Trainer in the exam and think it's all about the base. I need the base to be the same. I can't have them as different things, otherwise I can't use any power laws. So the link is spotting what they can all be written as powers of. And the biggest trick here is normally the smallest one. It's normally the 2. Or if it was like 3, 9, and 27, you'd use 3. Because I can write 16 as a power of 2, and I can write 8 as a power of 2. So the first step is actually replacing each of the base numbers so that they're the same. I want 16 to be written as 2 to the something. Okay, so 2 to the x is already a power of 2. But 8 is 2 times 2 times 2. 8 is actually 2 cubed. Okay, so 8, aka 2 cubed, is being raised to the 3/4. So that is still 8 to the power of 3/4. But I've dressed it up so it looks like a power of 2. 2 to the 3 is 8. So 2 to the 3 to the 3/4 is 8 to the 3/4. And likewise, 16 is 2 times 2 times 2 times 2 is 2 to the power of 4 to the 5th. 2 to the 4 to the 5th. There we go. It's even more fun. It sounds like you're doing some sort of rap. But 2 to the 4 to the 5th times 2 to the x is equal to 2 to the 3 to the 3/4. And whilst you're probably still looking at this like, oh, this is quite nasty, it's now in a user-friendly form. Like it's in a format that we can do stuff. We can use power rules. We couldn't use power rules here. The calculator wasn't going to save us. So we had to change it. We had to take ownership of the question and change the base to something we can actually do. So now I can start worrying about my power laws. Well done if you're working ahead of me, by the way. Feel free to like try and actually solve this before me. You can do that for every question. And then it doesn't matter like if you went wrong because we're going to go through it. But basically, we're just trying to tidy this up, and this ends up being a really nice comparison. So something 4 times a fifth, because when it's a power to a power, you times them. You're going to get 2 to the 4/5 times 2 to the x. And again, you times these together. 2. 3 times 3/4 is actually 9/4. If you're not following or you're not happy with how I've done this, please ask. I'm going to try and clarify. For those of you thinking, how did you just do 3 times 3/4? Remember, whenever you times a whole number by a fraction, you're only really affecting the numerator. Because 3 is like 3/1. So it becomes 9/4. Okay. In the same way, like if you have 1/5 and you times it by 2, you get 2/5. You got 2 of that thing. It affects the numerator when you times by an integer. So that's where we're at. And we are very, very close to getting the answer now. So at this stage, what we've got is we've got that classic, I'm timesing with the same base, so I just add the powers. And I know it's still a little bit disconcerting looking. How did I get? Good question. So I had 4. 2 to the 4 is 16, and 16 is being raised to the 5th. So I've done 4 times 1/5, which is 4/5. So think of 4 times 1/5, if it helps. That's 4/1 times a fifth. I did do that very quickly, so I really appreciate people checking things like that. And it helps me as well in case I've gone wrong. So please do like challenge it and ask. I hope that makes sense. And now, whilst it's still a little bit disconcerting, we are so close to the answer because we get 2 to the 4/5 plus x. Remember, when you times, you add the powers, equals 2 to the 9/4. And I know people are looking at this like, oh, that still doesn't look nice. But we're basically there. We've got a little linear equation now. This must just equal this. 2 to the thing equals 2 to that thing. The thing must equal the thing. We can just ignore the 2's. If 2 to that number, whatever it is the same value as 2 to that number, those two numbers have to have the same value. It's got to be the same thing. So I can literally write 4 over 5, 4/5 plus x equals 9 over 4. By the way, again, I'm going with like a nasty case scenario. So if you're following this, this is fantastic. I've seen a lot like nicer versions of this skill come up, but we've gone through and demonstrated it with, you know, quite a nasty one. So at this stage, I can literally just make the comparison and say 4/5 plus, no, let me get that right. 4/5 plus x equals 9 over 4. And I'm just solving this linear equation for x. So I can just rearrange the 4/5 to the other side. So x is 9 over 4 minus 4/5. And then, okay, if you have a calculator, you can do that. If not, we'll have to common denominator it and do addition or subtraction of fractions. Common denominator is 20. So I times this by 5 over 5, which would be 9 over 4 is the same as 9 times 5, so 45 over 20. And 4/5 times that by 4 over 4 is the same as 16/20. And then I can do that, take away that. So that would be 29 over 20. So it wasn't an overly nice answer. But the point I was trying to make for everyone, like I said, I've seen slightly easier versions of this question. They do come up, they will come up. The point here, when you're faced with something like this, take it step by step, but the absolute first step is change the base. Look for the link. They can all be written as powers of 2, or they could all be written as powers of 5. So if you had like 5, 25, and 125, use 5 and 5 squared and 5 cubed to start getting the base the same. Then you could just apply the rules, and then it ends up just being a comparison of the powers. So, very good question. When do you have to make this into a mixed number? So, to be honest, for something like this, especially on a non-calculator, unless they say, most mark schemes now will have this little code that says OE, which means or equivalent. So it doesn't, if they're not testing that skill, like early in the paper, it might be like, add up these fractions and give your answer as a mixed number, then fine, they're testing that. But at this sort of question, you could write 1 and 9/20, or you could write 29 over 20. They would give you that as equivalent. It won't matter for this question, because that's not the skill they're actually focusing on. It's only if they state that on this kind of question you would have to. But there's no harm in doing that, if that makes sense. So if you want to change it to a mixed number just as your default, go for it. That's fine. That's a good idea. Right. So what I'm actually going to do, I'm going to clear this off because I think I've got some, like a previously worked through answer that's going to fly in. I don't want it to crash with what I've just done. But that's a really good type of question to prepare for. If people face stuff like that in the exam, and they're like, I don't know, I haven't got a clue. Where do I start? Still really weird. And then that's exactly what we did. So, moving on. Here's another sort of similar situation. This time, it's all powers of 3. So we don't have to do that first step. But we do just need to make a comparison. And again, whilst it can be quite overwhelming to start with, this actually isn't that bad. It's all just using power rules. So let's do this together. So we've got 3 to the 2n plus 3 over 3 to the 4. Can we think about how we make a start there? What do we do in its division? So when it's division, you can just think of it, if it helps you, if you prefer, as thinking of it like this. You subtract, don't you? So it's kind of like 3 to the 2n plus 3 minus 4. And then here you add. So 3 to the 3 plus 1 minus 2n. Okay. Do take a moment to check we're happy, but remember, times in with powers of the same base, which we do have. You add the powers, you add the indices, divide and you subtract. Okay, now let's tidy this up a bit. And again, it's not too bad, because at this stage we can ignore the 3, because it's literally 3 to the that equals 3 to the that. The two that's are equal. These two things must just be equal. So you can ignore the base, and you can literally just go, let me highlight it, you can just say that equals that, and then it's a really easy linear equation to solve. So we could just say 2n minus 1 equals 4 minus 2n, and we solve for n. So bring the n's to one side, bring the numbers to the other. If I add 2n across, because I like a positive amount of n, I'm going to get 4n minus 1 equals 4, and add the 1 across, 4n equals 5, so n equals 5 over 4. Okay, so yeah, that's how you solve it. And again, it's fractional, you could give it a number. But it was all about getting the base tidied up and then making a comparison. And I think this is a really good question to look at this year's exam season. And you just do that comparison, as I said. So let's just check we're all good. Right, let's have a little look. Now, this one, what I'm going to do, I'm going to give you a minute or so, because there's a lot of me talking at you, to try this, because it's really sort of bridging the gap of the algebra and the number work. So it'd be lovely if you can give these a try. I just want to be quiet for a minute to give people a chance to see if they can get somewhere with these, because these follow up on the two skills we've just done. And then we're going to push ahead with the number and algebra work. Probably going to take a break in about 25 minutes, just a 5-minute kind of quick comfort break, maybe get yourself a drink or a little breather for 5 minutes. But right now, 1 minute for you to try these questions, and then I'll whiz through them. And then we're going to keep going with the number and algebra work up to lunch and really get the first part of the paper sorted with some extension bits in there as well. So yeah, really pushing the higher content. I know some people have asked about this, but the higher and the foundation do actually overlap. So this should be, as I said, this is prepared to be like attacking the higher content. But I don't know if you're aware, the last sort of half of the foundation paper is the first half of the higher. So there is and then the higher paper has some extra harder stuff in there as well. But there is a kind of core content that's on both papers, which is like a big bulk of questions. And then the higher just kind of gets progressively more involved. As I said, I'm going to be quiet, give you 40 seconds, 50 seconds maybe to make a start with this, and I'll start talking it through. And do feel free to ask in the Q&A at any point, and thank you to those who already have. Okay, so just as a reminder, the first one you might want to separate it out like we did, the different bits to that power. Try and find the easiest set of steps first, then just tidy it up. And the second one, remember all about the base. Can we write it as a power of one thing? And feel free to do these in either order. Another 20 seconds or so and I'll start working it through. Okay, so the first question, as I said, I would separate that out. And it's a little bit intimidating because we've got algebra and we've got kind of coefficients like numbers to worry about as well. And some people do the harder stuff right and they forget the easy bit with these. I would think of this as something to the third, to the 2, to the -1. They're the three things going on with that power. There's a half, there's a third, there's a fractional aspect, there's the 2 in the numerator, and it's minus. So the minus can kind of be done anywhere. It's just flipping it over. It's the reciprocal. The bit of advice I would give, I maybe didn't stress enough earlier, is when it's fractional, always do the fraction bit first. Not only to get the hard bit out of the way, but rather than, you don't really want to square that thing, like 125 squared, and then try and cube root that. You'd rather try and root it earlier on when it's an easier number to root. So we need to cube root then square the result and then flip the result. That's what this is saying. And you've got to remember, if you're cube rooting, these are cube numbers, so you can cube root them. But e to the 12 to the third, you can just times the powers there because it's algebraic. So that would just be e to the 4, like 12 times a third, or a third of 12. And f to the 3 to the third, a 3 times a third is 1. So what we would get is we would get 5, the cube root of 125, e to the 4, over 3 f, and I've cube rooted it. And you could check by cubing that thing and checking you get this. If I times that by itself, I'd get 5 times 5 times 5, 125, e to the 12, over 3 times 3 times 3, 27 f cubed. So I've cube rooted it. Then I want to square that, and then I want to flip it. So squared, it'd be 25 e to the 8 over 9f squared. And then I'm going to flip the result. So literally flip it, 9f squared over 25e to the 8. Okay. So that's that one. This one here, let's change them all to powers of what? What do we reckon? 2 to the half times 2 to the n over 3 equals 8 to the x over 4 to the n. I'd use base 2. It's normally the smallest one, as I said. And so the left-hand side is kind of what it is. It's all already powers of 2. I'd rewrite 8 as 2 cubed, and I'd rewrite 4 as 2 squared. So I would get 2 to the half times 2 to the n over 3 equals 2 to the 3 to the x, aka 8 to the x, over 2 to the 2 to the n. And now it's always powers of 2, and I can solve it. So I'm actually going to bring this one in. I'm going to bring this result in. But basically, again, on the left-hand side, you're going to get 2 to the half plus n over 3. And here, you're going to get 2 to the 3x over 2 to the 2n, which is the same as subtract. So 2 to the 3x minus 2n. And now we can just compare this and this. Now, this was a weird question because it's not actually solving for an answer. It says express x in terms of n. So you just make x the subject, ultimately, of that one. And I'm a little bit mindful of the time, so I'm not going to spend too long. But if you want me to go back over this one carefully, I'm happy to. But you're just going to kind of, from that point, do half plus n over 3 equals 3x minus 2n. Bring all the n's to one side, all the other bits across, and just get x on its own. And so the result here ends up as that. Okay.